Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on Simple Queue Service or SQS. And if you remember from the history lecture where we're talking about the history of AWS, this was the first ever AWS service that was publicly available. So this is the oldest AWS service. Now, where this comes up in the exam is you need to understand what SQS is at a very high level, and then you need to understand various different components of it. And it makes sense that this is in the exam because it is the oldest AWS service. So what is SQS? Well, it's a web service that gives you access to a message queue that can be used to store messages while waiting for a computer to process them. SQS is a distributed queue system that enables web service applications to quickly and reliably queue messages that one component in the application generates to be consumed by another component. A queue is a temporary repository for messages that are awaiting processing. So if all that sounds a bit complicated, don't worry. The easiest way to learn what SQS is by looking at an example. So let's say you've got a website that generates memes. So here you are, you've got your user and they want to upload a photo. So let's say we want to turn this into a meme. So we're going to upload this to a website, and that a website might store this photo in S3. Now, as soon as that's finished uploading, that might trigger a Lambda function. And what Lambda does is basically it sends all the data about this particular image to SQS. So what kind of data? Well, it's going to send the data as to what the top of the meme should say, what the bottom of the meme should say. It might, give data about the S3 bucket location, so which S3 bucket has it been uploaded to. It might pass data around the user, etc. And this sits in SQS as a message while it's waiting to be processed. Then you might have a fleet of EC2 instances, and what they do is they poll the SQS queue looking for messages, looking for jobs to do, essentially. Think of SQS as, basically a way of assigning jobs. It's like you put a job into the SQS queue, then your EC2 instances, when they're ready, constantly poll that queue looking for work. And so they find this message and then they're like, okay, great, I'm going to create the meme. So I'm going to encode it. So here it is. It says, hello, Cloud Gurus. And it then stores the EC2 instance, then writes that to the same S3 bucket, or it could write it to a different S3 bucket. And then once it's finished that job, it goes back to the SQS queue again and looks for work, looks for jobs to do. And you can actually have auto-scaling groups that sit behind SQS so that it automatically scales based off the SQS queue. So how many messages are in the queue could trigger you provisioning more and more EC2 instances. Now, the great thing about this is that if you lose an EC2 instance, you're not going to lose that job. It's still going to sit in the SQS queue, and another EC2 instance can go in and pick that up. And we'll talk about that in a couple of slides from now. So to give you another example, think of a travel website. It might be something like Skyscanner or Google Flights or something, and basically it will go out and scan a whole bunch of different airlines and get you the best deal. And if you actually work at Skyscanner, big shout out to you guys. I use you all the time. So here we are, we've got our user and they're looking for a holiday. So they want to package holiday and they want to get the best possible flights. So they type a query into their browser. This then hits an EC2 instance. So these are our EC2 web servers. And essentially what they do is they take what the user is looking for and they package that up as a message in an SQS queue. The queue then gets polled by an EC2 instance. So by polling, it's pulling the messages down. And this is really key because some exam questions will say that you need a pull-based system rather than a push-based system. SQS is always a pull-based system. If you want to use a push-based system, you use something like simple notification services, which we're going to cover off in a couple of lectures. So you've got your EC2 instances here. They're constantly polling the SQS queue, looking for messages, looking for a job to do. They then get that job and they process it and they say, okay, this user wants to fly from London to LAX or to LA, for example. Let's go and interrogate all the airline servers as to what the best flights are. Once it's got this information, it then sends that back to the web server, who sends it back to the user, and then the user chooses the best flights for his or her budget or his or her needs. I hate flying out really, really early in the morning. I like to fly out at 9:30 or something like that. So I want you to think about this if we didn't have SQS, and let's say the web server passed the information off to an application server. The application server then queried the airline servers, and let's say that application server crashes. What's going to happen? Well, your user is going to lose their query. The great thing about SQS is that if that application server crashed, the message will still be in the queue. It'll be marked as invisible, and this is called the visibility timeout window. But as soon as that timeout runs out, that message will appear in the queue again, and essentially another application server will pick that message up and process the job. So that's a great thing about SQS is you're removing dependencies. It's a great way of decoupling your infrastructure. So using SQS, you can decouple the components of an application so that they run independently, and with SQS easing message management between components. Any component of a distributed application can store messages in a fail-safe queue. Messages contain up to 256 kilobytes of text in any format. So you can have JSON, you can have XML, you can have plain text, whatever. Any component can then later retrieve the messages programmatically using the SQS API. The queue acts as a buffer between the components producing and saving the data and the component receiving the data for processing. This means the queue resolves issues that arise if the producer is producing work faster than the consumer can process it. So you think about that. The great thing about this is let's say you've only got 2 EC2 instances that are polling the SQS queue, and suddenly you're getting a ton of messages. What you can do is you can configure auto-scaling groups to monitor the SQS queue, and if it goes over a certain number of messages, let's say it goes over 10 messages in the queue, you then can start provisioning additional EC2 instances to process the messages in that queue. Likewise, you can have cooldowns, so say the number of messages in the queue drops down to 1. Maybe you only want to have one EC2 instance, so you can build auto-scaling in with this. So this basically brings elasticity to your application. And so let's move on. So there are 2 different types of queues. There's the standard queues, and now there's FIFO queues. And FIFO queues actually only just came out last year. So let's start with standard queues. SQS offers standard as the default queue type, so by default all queues would be a standard queue, and the standard queue lets you have nearly unlimited number of transactions per second. They guarantee that the messages are delivered at least once. However, occasionally, because of the highly distributed architecture that allows high throughput, more than one copy of the message might be delivered out of order. So standard queues don't have any kind of order to them. They provide best effort ordering, which ensures that messages are generally delivered in the same order as they are sent, but it can't be guaranteed. Okay, FIFO queues, however, do guarantee exactly that. So first in, first out. The messages will be delivered, be sent and received in the order in which they arrive. So the order in which the messages are sent and received is strictly preserved, and a message is delivered once and remains available until a consumer processes and deletes it. Duplicates are not introduced to the queue. So FIFO queues also support message groups that allow multiple ordered message groups within a single queue. Another thing to note about FIFO queues is that they're limited to 300 transactions per second. They have all the same capabilities of standard queues. Typically, you're going to be asked around standard queues. And really, where you're going to be quizzed on is just understanding what SQS is at a high level, and then these key facts. So always remember that SQS is a pull-based, not a push-based system. Messages are 256 kilobytes in size. Messages can be kept in the queue from 1 minute all the way up to 14 days, and the default is 4 days. And then visibility timeout is the amount of time that the message is invisible in the SQS queue after a reader picks it up. So we put a message in the queue, and then the EC2 instance pulls that message down and has a job. So it might be to create a meme, it might be to go and query the airline. And so that message is still in the SQS queue, but it's invisible. Now, provided the job is processed before the visibility timeout expires, the message will then be deleted from the queue. If the job is not processed within that time, the message will become visible again and another reader will process it. This could result in the message being delivered twice. So if you have your visibility timeout to, let's say, 1 minute, but the job that it's doing is something, let's say it's doing some big data analytics or something like that, what's going to happen is the message is going to come back into the queue because it's going to take over a minute. Let's say it takes 5 minutes to actually process that big data. The message message is going to become visible in the queue, I should say, not come back to the queue, but it's going to come visible in the queue, and then another EC2 instance will pick that up. So you could be delivering your messages multiple times because your visibility timeout is too low. So you've got to think about that when architecting your applications. And then finally, the visibility timeout maximum is 12 hours. So you can only, the 12 hours is the configuration maximum. So if something's going to take over 12 hours, then SQS is probably not a good choice for you because you're going to be delivering messages multiple times. SQS guarantees that your messages will be processed at least once. However, and you have to bear this in mind when architecting, it could be processed a couple of times, especially if your visibility timeout is lower than the amount of time that it takes for that EC2 instance to do the job. And then finally, there's a thing called SQS long polling, and this is a way to retrieve messages from your SQS queues. So normally you've got regular short polling and it returns it immediately. So you've got your EC2 instance sitting there going, is there a job, is there a job, is there a job? And it will keep doing that even if the message queue is empty. Now, long polling doesn't return a response until a message arrives in the message queue or the long poll times out. So the great thing about long polling is it's going to save you money because you're not constantly polling an empty queue. You're going to poll it, it's going to wait for the timeout, and then it times out, it's going to return a response saying, look, there's no messages in the queue. If you don't have long polling enabled, EC2 will just consistently poll the queue going, is there a message, is there a message, is there a message? And that can increase your costs. Okay, so what are my exam tips? Well, just remember what SQS is. It's a distributed message queuing system. It allows you to decouple the components of your application so that they are independent. So let's say an EC2 instance fails, and while it's trying to process a message, another EC2 instance will pick that up and the message will stay in the queue. Remember that SQS is pull-based, not push-based. You have two types of queues, your standard queues, which are your default queues, and that offers best effort ordering, and the messages are delivered at least once. And then you have your FIFO queues, and this is where order is strictly preserved and your messages are only delivered once. There's no duplicates, and this could be good for banking transactions where things need to happen in a strict order. We then have our visibility timeout. The default is 30 seconds. You need to increase this if your task is going to take longer than 30 seconds to complete. Also remember that the maximum is 12 hours. And then we have two types of polling. We have short polling, which is default and basically returned immediately, even if there are no messages in the queue. We then have long polling, and this will only poll the queue periodically and only return a response when a message is in the queue or the timeout is reached. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.